So here's a topic that sometimes comes up in your physics exam, black body radiation. So let's take a look at a question on it. It says, albedo is a measure of the amount of solar radiation reflected by an object compared to the total solar radiation incident on the object. So a perfect reflector would have an albedo value of 1 and a perfect absorber would have an albedo value of 0. So for the perfect black body that it's asking for here, what is the albedo value for a perfect black body? Now, a perfect black body is an example of an absorber, and it's the best possible absorber you're going to get. So if we look at the paragraph, it says a perfect absorber has a value of 0. So simply you're going to say 0 or 0.0 if they have in the question. That's your first mark. Now it says figure 3 below shows 2 points A and B just above the Earth's surface. And it says the average albedo value of the Earth's surface is 0.3 and albedo value of thick clouds varies between 0.6 and 0.9. And now it says at night, the air at point A, which we can see has no cloud cover above it, cools faster than the point at B with the cloud above it. So we need to explain for 3 marks here why the air at A cools faster than the air at B. So let's have a look. At night, there's no sun on the Earth as much in the region that you're in. So the amount of heat emitted from the Earth is greater than what is emitted from space. So you're emitting it back out into space, more than space going down to Earth. So that's the first mark. So here we're going to mention the key difference between A and B, where A will emit that radiation back up to space. For B, you can see it tries to emit that radiation, but then it reaches the clouds, and the cloud is therefore going to reflect it back because it talks about it having an albedo value between 0.6 and 0.9, closer to that of a perfect reflector at 1, so it's going to reflect that radiation back down onto the Earth. So it's going to struggle more. So for the second mark, we're going to say the cloud reflects the radiation back down to Earth at B. So for the last mark, we've said what happens at B, but for A, we know there's no cloud cover, so therefore a larger proportion of the radiation will be emitted into space, and that's why it cools down faster. So that's our third mark. So there you go, 3 separate points. That's where we can get you the 3 marks in the last part of this question.